climate change and natural disasters. So climate change can create natural disasters through a number of different mechanisms. So let's have a quick overview of them. So first, climate change can impact floods along rivers. For instance, floods along the Seine River, let's say in Paris. Second, climate change has an impact on sea level rise, which can lead to submersion of infrastructures on the seaside. Third, climate change can have an impact on the hurricane risk. Fourth, climate change can create wildfires, des feux de forêt en français. Fifth, in mountainous areas, climate change can create avalanches because of melting snow and ice. And finally, climate change can have an impact on subsidence, that is, on the movement on soil, which can lead to destructions of buildings. So what I propose is to go through each of these different impacts. So first, floods along rivers. Just to get a picture of what it is, here you can see a picture of Villennes-sur-Seine in the Yvelines, so close to Paris, after a flood of it was, I think, two years ago. And the idea is that climate change has an impact on rainfalls and on the hydrology of rivers. So, for instance, if you remember the lecture on water availability, you can remember that climate change in some places increase water available and in some others decrease the water available. And similarly, climate change in some places increases the risk of floods and in some other places decreases this risk. What is important here is that the impact of climate change on water availability is really different from its impact on flood risk. That is, there are several places on Earth in which, because of climate change, there will be, in average, less water available, but in which flood risk will at the same time increase. Why is it the case? Because quite often, not all the time, but quite often, flood risk is due to the probability of, if you want, just an extreme rainfall. Basically, when it rains a lot, even for a short time, it can lead to a flood. Whereas water availability is more related to the average rain every day. And in some places, climate change can increase the risk of extreme rainfall, but at the same time decrease the average rain every day. For instance, that is the case in the south of France. In Var department, close to the Mediterranean Sea, for instance, there it is expected that because of climate change there will be less water available to drink, but the risk of flood will nevertheless increase. Here on this map you can see a global overview of the impact of climate change on floods. So basically on this map, it's slightly misleading, but when the places are represented in blue, it means that the risk of flood will increase. And when the places are represented in red or yellow, it means that the risk of flood will decrease. And basically you can see that in a large part of the globe, the risk of flood will increase. So there are a lot of uncertainties actually on these figures, because I won't get into the details, but it's really difficult to actually relate climate change to flood risk. And for instance, if you look at the Seine River in Paris, it is expected that climate change won't have such an impact on the flood risk. A priori, it will more or less decrease the risk of floods on the Seine River, but it's not completely sure, and some people say that it might increase. And if you want, the global message is that quite often it's not so clear. By the way, another thing which is important on this graph is that you can see that the measures indicator here is what is called the flood frequency, and the unit, it's the return period in years. What does it mean? Is that generally when you speak about floods or about every natural disasters, actually, the one way to measure whether it's recurring often or not is to measure what is called its return period. So the return period is basically the average number of years in between two similar events. For instance, maybe you know that in Paris there was a big flood at the beginning of the 20th century in 1910, and this flood has a return period of 100 years. It means that it is expected, more or less, that such a similar flood will occur every 100 years. So it doesn't mean that a similar flood will occur exactly after 100 years, but that over a long time, let's say over several thousand years, you would expect, in average, such a flood approximately every 100 years. And so what is represented on this map is the variation of the return periods of the floods. So if you take a flood of a return period of 100 years, because of climate change, in some places the return period of the flood will decrease. It means that such an event will occur more often, whereas in other places the return period will decrease. So it means that such an event will occur less often. Because of this, it is expected, because of this change in flood risk, it's expected that more people than today, in average over the Earth, will be exposed to flood risk. So this graph here explains this. So it's slightly complicated, but basically on the y-axis you have the number of people exposed to floods in climate projections, and the different lines represent the different climate scenarios. And basically the idea is that for moderate climate change, as let's say this dark blue here, the number of people exposed to floods won't be so different from today. However, if climate change is higher than this, for instance, if you look at the yellow or the red scenario here, then you can see that between now and let's say 2050, there won't be such big changes of the number of people exposed to floods, but after this number of people will begin to increase, and will increase by huge margins. Another idea now which is important is the fact that when looking at cities, beyond climate change, urbanization itself contributes to creating floods. So why is it the case? Because you have to realize that when it rains in the countryside, what happens, and it's what is represented here on the left, is that so the rain goes on the ground, and a big part of it is just infiltrating in the soil. And only a small part of it, between 10 and 20%, is actually going into the rivers. When, because of urbanization, a big part of the soil has become impermeabilized, so one is not letting the water get through. The proportion of the water which is going from the rain directly into the rivers increases. And when you're in a city, especially in large cities, actually almost all of the water which is coming from the rain is directly going into the rivers. And so because of this, when you have a big city, the risk of floods due to the rivers is much higher than when you're in the countryside. So that's why currently there are many policies trying to increase the amount of water going into the soil, even in cities. We'll come back to this later. So now we have looked at the impacts on floods. Let's look at the second impact, which is impact on sea level rise. So just to illustrate this, sea level rise, it's something which may be a big impact of climate change depending on the location. So it's especially a big impact in small cities. So here, for instance, you can see a picture of Malé, the capital of Maldives, and it's a city which is quite dense and which is just built on an island which is very flat. You can see this on this picture, and so this is a city which is especially vulnerable to sea level rise. Actually, sea level rise is a big impact in two types of places. it's especially a big impact in small islands, but also a big impact in delta. Why is it the case? Because when you're in a delta, the delta of a river, when you're in a delta, first, it's a place which is generally very flat. So since it's very flat, as soon as the level of the sea rises, then the water can go far inland. And also it's a place which is extremely vulnerable to sea level rise, because when you're in a delta, you basically have water coming from everywhere, in front of you from the sea, and in your rear from the river. So when you want to get protected from rising sea levels, it means that you have to build dikes everywhere around you. So it's much more difficult to do. And the bad thing is that for historical and cultural reasons, deltas are places which are extremely populated, especially in Asia and in Africa. Let me illustrate this with a few examples. So here, this picture and the following pictures were taken from an article in The Guardian in 2017, which illustrated what could be the impact of sea level rise on a few cities in the case of a 3 degrees scenario. So a 3 degree scenario, it's a really high scenario of climate change. So we want to get into this. But it's at the same time a scenario which is realistic, because so far, if you remember what we said in the first course, we expect climate change at the end of the century to be about between 2.5 and 3 degrees if we continue as we do now. So let's see a few cities and how they are exposed to sea level rise. So here, for instance, you can see Rio de Janeiro, and here the places which will be flooded at the end of the century in a 3 degree scenario. So basically, in such a city, something like 2 million people will be affected. Another example of city which will be badly affected is Osaka in Japan. Here, in this case, it's more than 5 million people who will be submerged by sea level rise. Figures are even higher in Shanghai, in China. In this case, it's basically it's a really large part of the city which will be flooded, leading to something like 70 million people flooded. To take a last example, here you have a map of Miami in USA, and basically almost all of Miami will be flooded, leading to about 3 million people who will be flooded. So what does it mean? It doesn't mean that all of these people will be flooded. It means that something which have to be done, and either dikes will have to be built, or relocation will have to be done. And one of the big questions with sea level rise is this question of what kind of adaptation we will choose. Just to finish on this, here you have a map of a delta in France, the Rhône Delta, in which you have the Camargue, which is an area. It's not densely populated, but it's an important area for tourism, especially. And so you can see on this map what would happen with 1 meter sea level rise. So 1 meter sea level rise, it's what you get in a moderate climate warming. So it's highly realistic. And you can see that, for instance, in such a scenario, Les Saintes-Maries de la Mer, which is the important city there, will be submerged, as is Fos-sur-Mer. Just to finish on this, here you see an assessment of the transport infrastructures in France, which will be submerged in a similar moderate sea level rise scenario. And so, the idea here is that even in France, many infrastructures can be affected by sea level rise. And here again, the big question will be what we do about this, and we will come back to this later.